Okay, so we have a few examples to go over for solving equations. And remember our 5 steps, our parentheses, combining like terms, moving our x, moving our constant, and then dividing. So if we look at the very first example that we have here, we have 5x minus 12 equal to 7. So notice it doesn't have any parentheses, it doesn't have any like terms, and it actually, all of our x's sit right here with the 5x. So the first thing that we need to do to start isolating or getting the 5x by itself is to move that 12. So we are going to do that by adding 12 to both sides. Remember, we are working with equations, so whatever we do to one side, we have to do to the other. So then we're going to have 5x. Our 12's here are going to cancel each other out, and this is going to equal 19. So now all we have to do is get rid of this 5. Remember, whenever you're looking at something that's 5 times or 5x or something of that nature, this is a multiplication problem. So in order to get rid of that 5, we're going to divide by 5 on both sides. So the 5's over here are going to cancel each other out. And we're going to get that x equals 19 over 5. Now at this point we can actually leave this 19 over 5. It does not reduce since both 19 and 5 are prime numbers. Or you could go to your calculator and make it into a decimal, which would end up being 3.8. We just need to make sure that we pay attention to what our problem is telling us to do. So for our second example, we have 2x minus 10 equals 4x plus 4. So again, thinking of our 5 steps, we don't have any parentheses, so we don't have to worry about that. We don't have any like terms on the same side. And when we talk about same sign, it means if I cover up the 4x or the right hand side, I look at 2x minus 10 and there's nothing alike. And if I cover 2x minus 10 and just look at the 4x plus 4, there's nothing alike there. However, we do have an x on both sides of our equation, so we want to move one of these two x's. I typically like to move the smaller, which would be the 2x, but it doesn't honestly really matter which one you move. So in this particular instance, let's go ahead and subtract that 2x from both sides. Again, those two x's are going to cancel each other out, but we're still going to have that negative 10, and be real careful making sure that you bring that negative down with the 10, not just the number 10. So that's going to equal, well, 4 minus 2 is going to give us 2x plus 4. So now that we've moved all of our x's over here onto the right-hand side, that means that this 4 needs to be moved over to the other side. Again, thinking about our opposites, since it's a plus 4, we're going to subtract 4 from both sides. So now we have negative 10 minus 4. Since they're both negative, we're going to add them together and keep their sign. That's going to give us a negative 14 equal to 2x. And then we're back to our very last step, and that is to divide by whatever sits in front of our x, in this case 2. So we're going to divide both sides by 2. And negative 14 divided by 2 is going to give us negative 7 equal to x. And this would be our answer here. We wouldn't need to reduce it since it divided out evenly. All right, so let's look at question number 3 here. On this one, we do have parentheses. So the first thing we need to be doing is distributing this 5, and it needs to go both to the 2x and the 7. Make sure that when you distribute a number in a parentheses that it does go to everything inside of that parentheses. So that's going to give us 10x minus 35, and that's going to equal 4x minus 2. We're just bringing down that right-hand side since there was nothing we could do. Again, if we cover up the 4x minus 2, you notice that there's not any like terms on the left-hand side. Same thing is true if we cover up the 10x minus 35, there's nothing alike on that side as well. So we're down to moving one of these x's. Again, I always prefer to move my smaller, which in this case would be the 4x, but honestly it really doesn't matter. So we're going to subtract 4x from both sides. So when we do 10 minus 4x, that's going to give us 6x. We still have our minus 35. Again, our 4x's canceled each other out, so we just have that minus 2 left. So now we're going to move that negative 35, and again, we have to move him because he's on the side with our 6x, and we want to get him over to the other side. So we're going to do that by adding 35 to both sides. So again, we're going to have our 6x still. We haven't messed with him yet. Our 35s are going to cancel each other out, and that's going to be equal to 33. Remember, when you have two things that are opposite signs like this, where you have a positive 35 and a negative 2, you are subtracting them, and you're taking the sign of the larger number. That's why that will be a positive 33. So now we're going to divide by 6 on both sides. Again, dividing by the coefficient of our x. So over here, these are going to cancel each other out. X is going to equal. Now, for 33 over 6, unlike the first one, that actually does end up reducing. So if we want to leave it in fraction form, we need to come here and divide out a 3 top and bottom, since 33 and 6 are both divisible by 3. So 33 divided by 3 would give us 11. 6 divided by 3 would give us 2. So we could say that our answer is 11 over 2. Or we can do that in decimals just like we did that very first problem and say that this is 5.5. Okay? So for our fourth and final problem for solving equations, our examples here, we're going to do 2x times x minus 10 plus 4 equals 6x minus 12. Let me say that one more time. 2 times x minus 10 plus 4 equals 6x minus 12. And again, the first thing we want to do is distribute that 2 to the x and the negative 10. And that is going to give us 2x minus 20. And we're just going to bring our plus 4 down. We're going to bring our equal to and our 6x minus 12. Now this is kind of the first time we've had this, but if I cover up that 6x minus 12 and I just look at the left-hand side, I hope you notice that you've got this negative 20 and this positive 4. These are like terms. So we can combine those together. They're already on the same side, so you don't need to move them around. You just need to say negative 20 plus 4 would give me negative 16. So this would reduce down to 2x minus 16 equals 6x minus 12. Okay, so now we're kind of back to where we were for problems 2 and 3, excuse me. And we need to move either the 2x or the 6x. Again, I'm going to choose to move the smaller of the two, but it really honestly doesn't matter which one you move. So we are going to subtract 2x from both sides. So again, these guys are going to go away, those 2x's. We're going to have negative 16 equals 4x minus 12. Then we're going to add 12 to both sides. That is going to give us a negative 4 equal to 4x, and these 12's over here are going to cancel each other out. And we're down to our very last step, which is always to divide. So let's divide both sides by 4. And negative 4 divided by positive 4 would give us negative 1 equal to x. And this is our answer. By the way, if you ever get something like this where your x is on the right-hand side and you don't like the way that looks, you can also just reverse that and say x is equal to negative 1. These are the exact same statements. It's just a preference on the way it looks.